All right, well, it's time for us to do some practice with rates of change. In particular, we're going to focus mainly on the average rate of change. So that's how we're starting. We're going to do a lot of algebra today. It's a good way to start your calculus journey. The more algebra you can do, the better. Now, one word of advice. When you're doing these problems, the best way to get the benefit from these problems is to do them as much as you can on your own, and to only see the solutions if you're getting stumped or just to verify that you're doing it right. So make frequent use of the pause button. When you see a problem, try to get as far as you can before you unpause. And the more that you do, the better that you get, and you're going to be great. So let's start. First problem. Find the average rate of change for y equals 5x plus 219 from x equals pi to the 5th to x equals e to the 17th. Now, at first glance, there's a lot of things that seem intimidating about this problem. We see really kind of strange numbers, 219, pi to the 5th, e to the 17th. These are meant to distract us, to make us think like, oh, this is a hard problem. But let's not be distracted. Let's think about what's going on. What do we see? Well, we have a line. We know it's a line. It has that form, mx plus b. We're pretty good at lines. We can recognize them. So here's our curve. It's a nice flat line. And we're going from some number, I don't know, pi to the 5th. I'll say it's there. Some other number, e to the 17th. Let's say it's there. So I'm looking for the average rate of change. Now, we start thinking, well, what does average rate of change mean? Well, one way to think about average rate of change is if I have 2 points, it would be the slope of the line between those 2 points. Do we know the slope of the line between these 2 points? Yes, because we know the line. Our whole function was the line. And so this one, it really is not testing us on like, oh, let's try to do a formula. Let's try to, do something complicated. It's saying, do you understand? And boy, we want to understand. That's our goal. We say, aha, this is a line, and therefore the average rate of change will just be the slope, and that will be 5. And that's our answer. Good. Well, nice. Let's hope all our problems are this nice. I suspect they might get a little bit more interesting. And maybe I should say, I hope. It's always fun to do interesting problems. All right. So, find the average rate of change for this function, y equals e to the x plus x squared plus tangent of 2x from x equals 0 to x equals 5. Now, this problem is giving away what we need to do because it says the average rate of change. Now, once you see that, you really should say, hey, there's a formula for average rate of change. I should know the formula. Do you remember it? So the average rate of change is f of b minus f of a divided by b minus a. That's the formula. So we memorize certain things. So like average rate of change in output over change in input. So now we just have to say, well, what are our pieces? So in other words, what are our a, our b, and our function? Well, okay, here's our function. That's easy enough. This is our f of x. Which one is a and which one is b? Now, I'm willing to bet you would have said this is a and this is b. And that's because you're right, it is a and b. Now, what if you had said 5 was a and 0 was b? You'd also be right. You see, we don't say that a has to come before b. That's just sort of a convention. We just need, look, I just need 2. And I'm not caring about their order. And what's going to happen is if you swap the order, say, flip what a and b are, you'll flip the sign upstairs, but you also do the same thing downstairs, and 2 negatives will cancel out. Oh, it means you'll get the same answer. So we don't have to worry about which one comes first. We just have to say, well, what are they? And then we're good to go. So what do we do? Well, according to what we need to do here, we'll write this out. That's f of 5 minus f of 0 over 5 minus 0. Okay, so far so good. Easy enough. So we're going to plug in 5. All right, so plug in 5. E to the 5th plus 5 squared plus tangent of 2 times 5, which turns out to be 10. subtract, plug in 0. E to the 0 plus 0 squared plus tangent of 0. Well, tangent of 0 turns out to be 0. Okay, that's nice. So, all right, don't forget downstairs, 5 minus 0 is 5. So, as I already mentioned, I'll flip colors here. Tangent of 0 is 0. That's nice. 0 squared is 0. That's nice. So that makes things a little bit easier. E to the 0? Not 0. Be careful. E to the 0 is 1. Now, good. We're almost done. But before we go, I just want to point out, I utilize some really cool algebra technology, which is really cool. It's this fantastic point-saving device. And since we're just starting, I think it's important to emphasize this because a lot of people really overlook the power of what we're doing. Now, what's this wonderful point-saving device? It's called parentheses. Yes, these are fantastic tools. The more you get into the habit of using parentheses, the better you'll be. The reason I say that is sometimes you'll have things like a minus sign in front. And if you forget the parentheses, then you forget that the minus comes through. Now, in this particular case, it really doesn't change much, but that won't always be the case. And so, if you can get into that good habit, use those parentheses. You're going to save yourself a lot of points. And, of course, we don't do it just to save points. We do it to save heartache. Because, nothing's more frustrating than getting stuck. Or even worse, getting a wrong answer. Ugh. I once got a wrong answer. I couldn't sleep for a week. No. It happens all the time. Come on. Okay, so let's clean this up. E to the 5th? E to the 5th, yeah. 5 squared is 25, but there's also a minus 1. We'll put those together, get 24. Tangent of 10 is tangent of 10. And don't forget to divide by 5. Good. And that's our answer. Done. See, these are very simple. There's no surprises here. Now, let me ask you a question. Let's suppose I were to say that I gave you a quick sketch of this function. Now, I don't know exactly what it looks like, but I'm going to be roughly in the ballpark of what it looks like. It does the following. There's, because of the tangent function, there's these asymptotes. Now, because of the other pieces, it's really causing things to sort of shift around a little bit. So what's happening is we're kind of going between some points here. So maybe like from here over to here. And we're saying, what's the average rate of change? Notice that there's breaks in the function. There's these blow-ups. Does that affect how we compute the average rate of change? And the answer is no. The average rate of change, we don't know what happens between the 2 points that we compare. It might not even be defined between those 2 points. Or there might be breaks, there might be jumps. Anything can happen. All bets are off. Without additional information, we just don't know. And that's okay. It's okay that we don't know. All right. Okay, here we go. So, we're told f of 1 is 3, f of 9 is 11, and that the average rate of change of f of x from x equals 1 to x equals 4 is twice the average rate of change of f of x from x equals 4 to x equals 9. And now we're going to determine f of 4. All right, this is good stuff. Now, one of the things we have to start doing is we've got to start learning to translate. So we want to take our sort of English prose, not really exciting prose, but this writing, and we want to turn it into a mathematical formula. See, if we can get to that mathematical formula, then we can use our tools of mathematics, mainly we call them algebra, and then we can solve. Okay, so how do we do it? Well, we're just going to start parsing the sentence. Okay, so we have that, we'll start here. The average rate of change of f of x from x equals 1 to x equals 4. That's our first piece we're going to translate. So the average rate of change, it's a very specific formula. So that would translate as what? Well, it would be f of 4 minus f of 1 divide that by 4 minus 1. So that part right here translates into that piece right there. All right, well, that's good enough. All right, now let's go to the next part of the sentence that's important. Is. All right, that was a really quick visit. All right, is. What does is translate into? Well, it translates into equals. Okay, well, that's good. Okay. So we have the average rate of change from 1 to 4, and is equals. And then the next piece, well, let me change colors just to emphasize. It's a different piece. Twice. Okay. All right, now what does twice translate into? Well, it means 2 times something. All right. And now the last part, the fiesta de resistance, as they might say. The average rate of change from 4 to 9. And now that's very similar to the other average rate of change piece. So we say, okay, so that's f of 9 minus f of 4 over 9 minus 4. Good. So what have we done? We've translated this long statement into a nice mathematical formula. Now there's other things that we can do. Notice that we haven't used all our facts. So for instance, f of 9 equals 11. Well, that says I can come down here and I can make this an 11. And f of 1 equals 3, which means I can come down here and I can make this a 3. All right, well, cool. So let's clean this up a little bit. So what do we now have? F of 4 minus 3 divided by 3 is equal to 2 times 11 minus f of 4, divide that by 5. Aha! Cool. Now, notice what do we have? We have one equation. And how many things we need to figure out? One thing. That's the right number of equations and things to figure out. In fact, it's a perfect number. So, how do we finish? Well, let's begin. Now, what do I see here? I see fractions. I'm going to tell you many times in calculus, fractions and me, we get along well enough, but I tend to be challenged with fractions. I've noticed in the past I've made mistakes with them. So, as much as I can, I strive to remove them, just because I want to limit the number of mistakes I make as well as simplify my computations. So, one of the best ways to remove is one thing that we have called cross multiply. So I'm just going to clear out the fraction. So I'm going to multiply both sides by 5. So 5 times f of 4 minus 3, and multiply both sides by 3 is 6 times 11 minus f of 4. Distribute through. 5 times f of 4 minus 15 is equal to 66 minus 6 times f of 4. Okay, and we're almost there. Almost there. We're going to move things around. So the idea is combine things that are similar. These terms all have f of 4. They're similar. Let's put them together. All right, and if we do that, what do we get? We get 11 times f of 4, because there's 5 here, 6 more are coming in, is 66 plus 15, and that's 81. Okay, and now we're almost there. I just need to get rid of that 11, and I do it by dividing. So f of 4 is 81 over 11. Just like we thought when we started. Well, probably not just like we thought when we started. It's not so clear that when you start the problem that you're going to end up with kind of this really kind of unpredictable number. But we don't have to guess. We have systematic, methodical ways to find things. And that's kind of the best thing, is when you have something which you can systematically and methodically discover all the fun and interesting things you may encounter. Oh, this one looks good. They all look good, right? Look at that. It's like an essay. All right. Looking over your lab notes of an experiment where you are looking at the height of a certain object in meters at a given time in seconds, you note that you recorded the following observations. So at 1 second, the height is 3 meters. At 8 seconds, the height is 1 meter. You recall that you made one more observation, but you've lost the data in your notes. Keep the data. Don't lose anything. All right, but you do recall the following. From the first observation, we'll call this our first observation, to the missing observation, the rate of change was equal to 1. From the second observation to the missing observation, the rate of change, or I should say the average rate of change, was -2. Now the question is, when did you make that missing observation? What was the time when you did that? And for added fun, and who doesn't want to add fun when they're doing math? We're going to do this using as little algebra as possible. So our goal is no algebra. And I know you're like, what, Steve, you love algebra. And I do love algebra, but I also love geometry. Calculus has a wonderful, rich geometrical intuition. And if you try to obfuscate too much with algebra, you miss out on the beauty of the geometry. Okay, so let's figure out what's going on. Now, I've come prepared. I have a grid here. So, all right, how can we use our grid? Well, first off, we should say that there's 2 directions. Each direction is associated with a different type of thing. So we're going to have the horizontal axis. That's going to be our time. So we're thinking that our seconds. The vertical axis, that's going to be our height. So in our case, like our meters. So let's figure out how to translate these 4 little bullet points into this picture. So let's first off just make these observations. At 1 second, the height is 3 meters. So we come to 1, go up to 3, and we make our dot. That's our observation. At 8 seconds, the height is 1 meter. So here's 8, and we go to 1, and we make a dot. All right, so good. Progress. Now, what's the next thing? From the first observation to the missing observation, the average rate of change was equal to 1. Now we have to think about, well, what does that mean? And here's sort of the idea, and this is a really cool idea. One way to think about the average rate of change is it's kind of like a slope. Remember, it's like change in y over change in x, which means that wherever the other observation is, if I were to connect that to this point, it would make a line with a slope of 1. So I can conclude that wherever that missing observation is, it would have to be on this line. So in other words, I have to pass through that point, that observation, and I have to have a slope of 1. And I can use my little grid here to figure out what a slope of 1 looks like. Now, why do I say that? Well, see, if my missing observation was down here, my slope would be less than 1. Doesn't work. If my missing observation was up here, my slope would be above 1. Doesn't work. But if my missing observation is anywhere on this line, I have a slope of exactly 1. Perfect. All right. Now, that's that part. But remember, we have something similar going on here. From the second observation to the missing observation, our average rate of change was -2. Again, let's think slope. So I'm going to come to my second observation and do a slope of -2. So that's going downhill, which if you were to run backwards, means you're going up. Okay, so here I am running backwards, and I'm just going to do that here. So that means wherever the second observation is, it has to be somewhere on that line. And now we sort of say, we don't have to say for too long because we're thinking like, where could it be? Where could our missing point be? I suspect it's where X marks the spot. Because it has to be on both these lines, which means our missing observation is very convenient. It happened to fall on a very nice coordinate. Now, see, this is when we can use the fact that our picture was nice. If our picture had been like, well, we can see they intersect, but it's kind of weird, then we have to pull out a little bit of algebra. But we don't have to for now. So we say, aha, this happens at time 5 seconds. So we know when the missing observation occurred. It happened at time 5 seconds. Now, could we say more? Oh, absolutely. For instance, we can now say not only was the missing observation happening at 5 seconds, but the height at that time was 7 meters. But, we don't need to show off too much. We just need to answer the question which was asked. And we've done that. So good for us. Good for us. Okay. Now, our next problem. If the average rate of change of f of x from x equals 1 to x equals 4 is 1, and the average rate of change of x times f of x from x equals 1 to x equals 4 is 6, find the average rate of change of x squared f of x from x equals 1 to x equals 4. Now here, we always are going from the same point, 1 to 4, 1 to 4, 1 to 4. So, all right, what's happening here? Well, in some sense, what's happening is we're changing our function. So originally it was our unknown function f of x, and then it's a modified function, x times f of x. And then we said, look, we're not even satisfied with that. We'll modify even more, and we'll have x squared f of x. So how do we approach this? Well, let's do what we would normally do. Let's translate this into some algebra. So we're told the average rate of change of f of x from 1 to 4 is 1. So this is our first statement. So here's our function, here's our a and our b, and is 1 equals 1. So our first statement becomes f of 4 minus f of 1, divide that by 4 minus 1 equals 1. And let's just go ahead and get rid of our fractions really quickly. Or we can say f of 4 minus f of 1 is equal to 3. Okay, that's good. Now, our next statement. The average rate of change of x times f of x from 1 to 4 is 6. Okay, now be careful. Our function isn't just f, it's x times f of x. So when we plug in 4, we're going to have 4f of 4 minus 1f of 1. Divide that by 4 minus 1 equals 6. Is 6. Or, another way to write this, 4 times f of 4 minus f of 1 is equal to 3 times 6, 18. Now, what do we have here? We have our classic 2 equations, 2 unknowns. All right, you're going to see a lot of this happening, where you have 2 or equations, 2 unknowns. Sometimes you might even do 3, very rarely though. So, how do you do 2 equations, 2 unknowns? Well, that's definitely an algebra thing. There's a couple of different ways. A lot of people like to say, let's solve for one of the variables. Maybe I can solve for f of 1 in terms of f of 4, and then I can make progress. Another thing you can do, and this is what I like to do, it's a personal preference. Again, there's many ways to do this. The important thing is not to do it my way, but to do it a way that you understand, and, this is important, you'll get the correct answer, because we like correct answers. So, what I like to do is I like to think of how can I combine these equations together to do some elimination. So, in fact, really both things are the same. Our goal is let's knock out one variable. Let's get down to a smaller set of equations and a smaller number of variables. So I want to think about, okay, how can I combine these in a smart way that gets us down to a simpler expression? So let's suppose I want to knock out these f of 1's because they're almost the same. Well, what I can do is, since they really are almost the same, a minus f of 1, a minus f of 1, I can take the second equation and I can subtract it from the first equation. And if I do that, f of 4 minus 4 times f of 4, well, that's minus 3f of 4. Then the f of 1's cancel. Oh, that's good stuff. See, we chose it to cancel. 3 subtract 18, well, that's negative 15. Right away, I see 2 negatives. I'll make them both positives. and divide by 3, we come to the conclusion that f of 4 has to equal to 5, right? 15 divided by 3. Now, I have f of 4. What do I do with that? Well, I can now come back in. Doesn't really matter where. Let's say I plug it in here. 5 minus f of 1 equals 3. Well, I know a number that does that. That tells us that f of 1 would have to be 2. So, we've now solved for what f of 4 and f of 1 are. Cool, but why are we doing that? We probably should have figured out why we were doing that ahead of time. In some sense, it's sort of like, well, I have to use the information given, and that kind of forces me into it. But let's talk about what we were looking for. That was really, in retrospect, we really should always make an idea of what we're looking for before we start looking. It's always good to have a target in mind. See, what we were looking for is we were saying we want our answer to be, again, average rate of change, plug in 4 squared f of 4, subtract 1 squared f of 1, divide that by 4 minus 1. So the reason we did all that was we really did need to know what f of 4 and f of 1 are because we needed those numbers. All right, well, now we have them. So 4 squared and 16, oh wait, no, that's not right. 4 squared times 5. That's 16 times 5. That's 80. Minus 1 squared times 2. So that's minus 2. Divide that by 3. All right, well, that's 78 divided by 3. And now, this would be, if you had a calculator, for instance, you could do what's 78 divided by 3. Well, it turns out that 78 can be divided by 3. And it's 26. It's good to sort of get into the habit of being able to do that. Now, there's lots of ways you can do that, but of course, practice. It's easy to tell, by the way, that 78 is a multiple of 3. There's this cool trick. I don't know if you know this. So here's the cool trick. If you just add the digits up and say, are the digits, just add those up, is that number divisible by 3? And if it is, then the original number was also divisible by 3. So 7 and 8 is 15. That is a number that's easy to see is divisible by 3. All right, good. Nice problem. Well, of course, aren't all problems nice problems? I think so. Now, so far, most of the problems that we've talked about are about average rate of change, and it's been a lot of fun, lots of algebra. Woohoo! We love our algebra! But it hasn't been feeling very calculus-y yet. So, let's delve in and do a more calculus-flavored type problem. And here we go. So, find the tangent line to the parabola y equals 3x squared minus 7x plus 3 at x equals 2. All right. Now, we see, what are we after? Well, we're told a line, because it tells us right there, we're after a line. Now, whenever we're looking for a line, we always think in the back of our head, if I'm looking for a line, there's really two things I'm looking for. So what are my two things? So for a line, I need a point and I need a slope. Every line I'm ever going to find, I'm always going to ask the question, what's my point? What's my slope? And almost always the point is the easy one. Almost always. 99% of the time. And that means it's probably the easy one right now. So how do we find our point? Well, we actually have some of our point. We're at 2. Okay, so that's cool. So let's use that, comma. And now how do we find the other part? Well, now here's our chance to sort of remember, what does it mean to be a tangent line? Tangent means touch. So we're going to touch the curve at 2. So that means that the y-coordinate for our point has to be the same as what's happening with the function at 2. So we're going to take 2 and plug it in. So 2 squared times 3 would give us 12. 7 times 2 minus 14. And 3 would be 3 again. So if you put that together, 12 plus 3 is 15. Subtract 14 gives us 1. There's our point. All right. So let's see. So we have this spread. It is opening up because it's a positive number in front of the x squared. And I don't know, right now that's about as much as I can say. But it passes through something like here. So let's say this is the point 2, 1. Now what's the other thing we need? The other thing we need, and this is the important thing, is our slope. Okay, so the question, what is our slope? Now this is where we're going to start delving into sort of something that feels more calculus-like. And the thing is, I cannot get a slope from a single point. Slopes need 2 points. So what we're going to do is we're going to say, let's not try to figure out the slope of our tangent line right away. Let's think about having a slope of a secant line. So let's suppose we'll say this is, I'll say B. So I have this point at B, and I'll call it B, comma f of B. Over here, there's this point 2, 1, which I know about. And now, what I want to say is, all right, my slope of my secant line is what? Well, it would be our, I'll call it f of b minus 1. So difference in the y coordinates. Divide that by b minus 2. Difference in the x coordinates. So far, so good. All right. We say, Let's figure this out. So I'm going to plug b into our function. And what will that give us? Well, 3b squared minus 7b plus 3, subtract 1 over b minus 2. Or if you like, that would be 3b squared minus 7b plus 2. Divide that by b minus 2. Okay, so far so good. Now we say, hey, what we want to do is we want to move b closer and closer to 2. All right, well, let's just ask ourselves a question. What would happen if we plugged in b equals 2? Well, upstairs you'd get 12 minus 14 plus 2. That does not look very promising. Downstairs we'd get 2 minus 2. Not very promising. That looks like 0 over 0. Now, 0 over 0 is not 1. Not usually anyways. In fact, handling 0 over 0 is non-trivial, and we're going to talk about that another day. But how are we going to handle it here? So for now, what we're going to say is, I know when I plug 2 into the upstairs, I got 0, because when I plugged 2 into the upstairs, I got 0. That was my first clue. It's a really good clue. That tells me that if I look here, 2 is a root of this polynomial. Now, so far, I haven't said anything crazy. I mean, it's easy to see that that has to be the case. But that gives me information. See, if I know that 2 is a root of the polynomial, that means that this polynomial has to factor in a way where I'm going to have 2 as a 0, which means that one of the factors looks like b minus 2. And remember, there's still a b minus 2 downstairs. I'll put parentheses just to make these look like they're the same thing. Like, ooh, they look pretty close to each other. Yeah, they do, don't they? But what's the other one? Now, at first glance, this looks like it's going to be a challenge for us to figure this out. But once you have one root and the one factor, the rest of it is oftentimes pretty easy to figure out, because we say, well, whatever comes into this slot right here, when I multiply b times that, I have to end up with 3b squared. So b times what gave me 3b squared? Well, that is 3b. And then I say, okay, now this last number, minus 2 times whatever this number is, has to give me the plus 2. So minus 2 times what gives me plus 2? Well, the answer is minus 1. And now we're done factoring. That wasn't so bad. Now we should check, right? So let's see, 3b squared, good. Minus b, minus 6b, good. Plus 2, it's all good. It works out. Now here's our great aha. The b minus 2's cancel. So what it really says is, this slope, if you give me a choice for b, it's 3b minus 1. And that's the choice for any b. Well, which b do we pick? Well, we're interested in what happens to this as b gets close to 2. And I think we can all agree that as b gets close to 2, that what will happen is I'll get close to 3 times 2 minus 1. And so in other words, it's going to the number 5. Ah, cool. So that tells us what our slope is. Our slope is 5. Now I have the slope of the tangent line. I have the point it passes through. So the last thing for us to do is to write our answer. And that's a really important step. We put a lot of work into it. We should celebrate by writing what the answer is. So y minus our y-coordinate is equal to our slope times x minus our x-coordinate. Sometimes this is the form y minus y naught is equal to m times x minus x naught. So let's clean this up. Now, I will say, if not specified, perfectly valid way to leave an answer. But we can go ahead and clean up a little bit more. So we can say that y minus 1 is equal to 5x minus 10. So in other words, I'm multiplying that 5 through. I'll move the 1 across. So we get that y is equal to 5 times x minus 9. And there we go. That's our tangent line. Our first tangent line that we found. Our first of many more to come. Because we're going to be doing that a lot. And I mean a lot. We're going to be finding tangent lines so often, we're going to be like, wow, that's another tangent line. Look at us. We're tangent line finding fools. Woohoo! All right, we should do a few more problems. Okay. If the average rate of change of f of x from 1 to 3 is 2, and the average rate of change of f of x squared from 1 to 3 is 20, determine the average rate of change of f of x cubed from 1 to 3. So, this is interesting. And I like interesting. It's a little bit different. This is really a chance for us to, again, we're doing a lot of practice with algebra today. So it's a great way for us to ease our way into calculus, like, oh yeah, there was algebra stuff. It's nice to see that we're using it now. So we're going to have some statements here. So we have the first one. The average rate of change of f of x from 1 to 3 is 2. So we have that f of 3 minus f of 1. Divide that by 3 minus 1, and that's going to be equal to 2. All right. And let's go ahead and just clean up our fractions right away. So that says that f of 3 minus f of 1 equals 4. Good. Now, the next statement. The average rate of change of f of x squared from 1 to 3 is 20. So now our function that we're looking at is not f of x, it's f of x squared. So f of 3 squared minus f of 1 squared, divide that by 3 minus 1. It's not 3 squared minus 1 squared. No, it's just the x values. The x values are 3 and 1 equals 20. Again, we can say that this becomes f of 3 squared minus f of 1 squared equals 20 times 2 is 40. All right. Good. Now, these are given. So, it's nice to know what's given. What do we want? Well, let's switch colors if we're going to talk about what we want. We want to know the following. We're looking for the average rate of change of the function cubed. So that's f of 3 cubed minus f of 1 cubed. Divide that by 3 minus 1. All right. Now we can kind of see where we're going. We say, well, if I want to know this expression, what I really need is what is f of 3 and what is f of 1. If I knew that, life would be good. Well, of course, life is always good. But maybe I should say life would be really good. And, we like it when life is really good. So how are we going to get there? Well, let's think here. Now here we have two equations and two unknowns, but notice the squares. At first glance, that may make us say like, what can we do? But we do not panic overly much. We're like, this feels familiar. Why do I say that? It's a square minus a square. If you like, you could call it a difference of squares. Okay, I'll call it a difference of squares. So what does that mean? Well, you might recall, and this is a good fact. It's one of those things you always want to keep in your back pocket so that you can pull it out and say, aha, I know what this is. So if I have a squared minus b squared, that is a minus b, a plus b. We use this a lot, so it's good to remember that. So what can we do? Well, we can take this side and rewrite this. F of 3 I can think of as the a, and f of 1 I can think of as the b. So a minus b, a plus b, and then of course that's equal to 40. Now, how does this help us? Well, have we seen this f of 3 minus f of 1 before? Have we seen anything that looks like f of 3 minus f of 1? Oh, it's right here. Ha ha ha. Okay, so I know that f of 3 minus f of 1 is 4. So I can now divide through by 4. So that allows me to come to the conclusion that f of 3 plus f of 1 is 10. Now let's rewrite that one. F of 3 minus f of 1 is 4. Well, let's combine. And I'll just add these up, because I can see when I add, the f of 1's cancel out. So add 2 times f of 3, cancel, equals 14, which tells us that f of 3 is equal to 7. And now I can say, well, 7 plus what gives me 10? Well, the answer is 3. And you can also check, 7 minus what gives me 4? The answer is still 3. So we say, aha, look, we're done. Well, no. We made a really good step. We got to finish up, though. We got to put these into there. So we're almost there. So this is 7 cubed minus 3 cubed. Divide that. 3 minus 1, by the way, is 2. Now, this is a great time for a calculator. But you might happen to casually know that 7 cubed is 343. Either way, you can make progress. So you might wonder, why don't I know that 7 cubed is 343? Well, it's just I had to take a class in college, and the course number was 343, and I was like, 343, I wonder how that factors. I think people often do that. They sit down and say, I have an interesting number to work with. I wonder how that factors. Now, 3 cubed, I think we all know. That one we can do. 3 times 3 is 9. 9 times 3 is 27. So 343 subtract 27 all over 2. Now, 343 subtract 27 sounds bad. What if I just said 43 subtract 27? You'd say, that's not so bad. That's 16. Well, now you have an extra 300. So that's 316 divided by 2. Again, you might think, well, that sounds bad, but break into parts. 300 divided by 2, that's easy, that's 150. 16 divided by 2 is 8. Put those two together, gives you 158. Aha! I don't think I would have guessed that before we started. But that's the great thing. We don't have to guess because we have algebra. Good stuff. Good stuff.